By the end of this lesson, you should be able to define pressure and state that the pressure P equals to force over area. Describe applications of pressure. Solve problems involving pressure. Observe the footprints closely. Why do the footprints have? Are they due to the difference in weight, size of shoes, soles of shoes? The force acting on the ground is due to the weight that acts normally on the surface. In this case, the normal force of the father is the greatest. Hence, normal force F does not necessarily affect the depth of the shoe's sink. Observe the surface area of the soles of their shoes. Whose shoe sole has the least surface area of contact with the ground? The surface area of contact of the mother's shoe is the least, and the mother's shoe sinks the deepest. So what causes the depth? The depth is due to the pressure exerted. Pressure is a measure of how concentrated a force is. A force can produce a high or low pressure depending on the area that the force is exerted upon. A normal force exerted on a smaller surface area will result on a higher pressure. The aim of this experiment is to find the relationship between force and pressure. The surface area in contact with the surface is kept constant. Force is the manipulated variables that can be changed by clicking on the three objects shown. The responding variable is the depth the sponge depresses. This represents pressure. Choose any value for F to start the simulation. Click the Reset button to change the value of force F. From the observation, what can we say about the relationship between pressure and force? Pressure is directly proportional to force. We can write P is proportional to F. Let us determine the relationship between surface area and the pressure with constant normal force. Surface area is the manipulated variables and can be changed by clicking on the three objects shown. Similarly, the responding variable is the depth the sponge depresses, which represents pressure. Choose any values for surface area A to start the simulation. Click Reset button to change object. From the observation, what can we say about the relationship between pressure and surface area? Pressure is inversely proportional to the surface area. We can write P is proportional to 1 over A. As you know from the experiment, as force acting on the sponge increases, pressure also increases. But as the surface area of the object increases, pressure decreases. So we say pressure P is directly proportional to force F, but inversely proportional to surface area A. Thus, pressure is defined as the force acting normally on a unit surface area. Pressure equals normal force over area. P equals F over A. The SI unit for pressure is Pascal or Newton per meter squared. Now let us see some of the applications of pressure. Why do you think the onion is easier to cut after the knife is sharpened? By sharpening the knife, the surface area decreases, thus increasing the pressure acting on the onion. Why do you think the tractor can move easily on soft, muddy ground as compared to the motorcycle? The tractor, even though it's heavy, has large tires which result in bigger surface area of contact with the ground. This reduces pressure and prevents the tractor from sinking into the ground.